Before watching this video, you should watch the one about how to do it using a tripod. It describes the setup and use of two smartphones at a location with two people to make the observations. The basic information about that in the tripod is in that video and won't be repeated here. As noted there, you can just point your phone B at the sun and record for 2 minutes around the time of central eclipse that we need, maybe steadying your arm against the top of a low fence or so, and whatever. But then the person operating phone B needs to watch its screen to keep the eclipse sun in the field of view. It will make a better view with less shaking if phone B can be set motionless by itself to record the eclipse, freeing both people at the location to enjoy and watch the eclipse directly during the most interesting 2 minutes. The recommended way to keep the camera still is to use the photographic tripod as described in the other video, but if you don't have one, we'll describe how to do that now. But first I want to describe the visual observation of the eclipse by at least one of the observers, which I forgot to include in the tripod video. During the minutes surrounding the central eclipse, that is starting 30 seconds before the central eclipse time for your location, it will be safe to look at the eclipse sun by naked eye. The brightness will be changing rapidly, and we want you to call out when you think the last bright part of the sun disappears, leaving only the red or pink chromosphere visible, and again when the chromosphere brightens and is overwhelmed as the bright surface of the sun reappears. These are called second contact and third contact, respectively, the start and the end of the total eclipse. That's all that observers lined up at the edges of past eclipses could do. We want to compare the visual impression with the recorded one. As soon as the sun becomes too bright to comfortably look at, start using the eclipse glasses to see the now expanding crescent of sunlight. Okay. The other approach, without using a tripod, is to just put your cell phone down on the ground and let it record by itself. But it needs to be pointed at the sun, so I will describe how to set your phone at the right angles to do that. You should test this procedure someday between August 17th and 20th, when the sun will be in the same position of the sky to good enough accuracy at the August 21st time of central eclipse at your location. If you center the sun 2 minutes before central eclipse, even at 4.0 magnification, which we want, the sun will stay in the field of view for the next 3 minutes that are needed. Now, due to the Earth's rotation, the eclipse sun will move from left to right across the field of view, so if you place the sun on the left side of the field at the start, it will stay in the field of view for the longest time. Now, for placing phone B on the ground to record the eclipse, it needs to be pointed in the direction of the sun, using its known angle above the horizon, or altitude, and the direction at your location. In order to use these angles, you need to be on a level surface. Carpenters are usually careful about making decks level, so they make good surfaces to use. But if you are on a sidewalk, it might not be level enough if the road is on a small hill. Use a level device to check it. We'll do that soon. If necessary, use a flat surface such as a card table with legs folded in, a piece of plywood, or even a large piece of cardboard cut from a large box, and place some magazines or other objects to prop up on the downhill side until the surface is level. Now, the first angle for the sun is the tilt angle to the horizontal. It's called, astronomers call it the zenith distance, we'll just call it the tilt angle, and it's 90 degrees minus the altitude of the sun above the horizon. For this demonstration, we'll use 64 degrees for the altitude, which is the maximum altitude of the sun above the horizon in the eclipse path from Missouri to western Kentucky. Then the tilt angle is 90 degrees minus that 64, or 26 degrees. Now the direction, which will generally be towards the south, is called the azimuth. The azimuth of directly south is 180 degrees. Most cities in rural areas have a grid of north, south, and east-west streets. Most in Kansas City are that way, but not St. Louis City. For our demonstration, in early July in Maryland, the sun's azimuth will be 124 degrees when the altitude is 64 at 11:40 a.m. Eastern Daylight Time. So for our demonstration, we will use the angle tilt angle of, or the direction angle, 180 degrees minus 124 degrees, or 56 degrees east of due south. I will use a protractor to plot these angles, the tilt angle 26 degrees and the direction angle 56 degrees, on a piece of thin cardboard that can be cut for positioning the smartphone. Thin cardboard, this is just cut from a Kleenex box, is better than just a piece of paper because it's stiffer. So we want to plot 24 degrees and 56 degrees. I'll just draw two horizontal lines. Okay, so this will be for tilt and direction. Okay, the tilt angle is 26 degrees, so I use this protractor. And I will be providing these angles to observers in eclipse path location. So that's 26 degrees, 10, 20, 30, 26. Okay. And we'll plot, let's see, now that was from the end, right? Okay, we'll use it, put the center at the end here, and we want 56 degrees. Degrees. Okay. So there we have our angles. 26 degrees, 56 degrees. And now I'll cut these out so we have these wedges. All set. First we check to make sure the deck is level. You can see the bubble there. It's within the two things. It's certainly level enough, and check it in that direction. So maybe in a couple of other places. But you can see it's no problem. That's a little bit off, but as long as it only has to be within 2 degrees or so, and this is, I think this full range is that, so we're good enough on this deck. But as I said, if you're in a beside the road on a sidewalk or something, you might have to prop something up on a flat surface. But I have this collapsible black box that you can buy for $7 or so. Turn on. Okay, swipe. Okay, we'll go to the GPS test. And what we need first is the direction. That's the north-south just for this location. Okay, and next we need the direction angle. We have to be 56 degrees east of due south, so that means the sun has to be in that direction. So the cell phone has to be put like this. The cell phone. Okay. This is a self-setting clock, a radio-controlled clock. It's always useful to have these things that shows the precise time. It should be better than a second. It gives a completely independent time source. But they're getting harder to find these days as people rely on their cell phones, which unfortunately the time is not yet accurate. Hopefully for the 2024 eclipse they'll solve that problem and have accurate cell phone time, and then we won't need to do the calibrations that we're trying to do now. Okay, I've recorded the coordinates. Now I'll switch to the time sync. Sync and internet time. Okay, so now we've got a good view of it, and we're still recording. There, we've got the time calibration now. Now we're ready to finally do the eclipse. This is the afternoon opportunity with the sun altitude 64 degrees. So I have it now at the 4 times zoom. So I'm going to start the camera here. It's starting to record now, and I'm just going to get sync, internet on. Okay, and we're still recording, and we've got some good time there, just for a few seconds. That's it. Okay, so now we set the we've already got this aligned with north here, and we're at 56-degree direction west of south this time, and so we just have to put the, so I want to verify that we're still recording it for, okay, we just have to set it up in this direction like this, at the 26-degree tilt angle. Should be it. Okay. And now, okay, well, I don't see anything because there's no eclipse, but if there were an eclipse, I would say, okay, now the sun has disappeared. The last part, I just see the chromosphere now. And now the chromosphere is getting brighter. Oh, there it is. Okay, that's the reappearance of the photosphere. So, the eclipse is over. Okay, and now all we have to do is, I don't know if I stood in front of the camera then, of course be careful of that, but all I have to do is record the time. First, there's the atomic clock, so-called self-setting clock, and it says network error, so we'll switch to GPS for the smart time sync, and sync, and we're done. Okay.